What is good, guys? My voice is kind of messed up today, but I'm still doing the video. So the last 2 weeks I've been doing forms of corrosion, types of corrosion. Now we're talking more about where corrosion happens and what it attacks. So today, atmospheric corrosion, we're going to talk about how the air attacks the metal. So the air attacks the metal by the main component of humidity, okay? Either wet air or dry air really affects how corrosion, the rate of corrosion. So wet air causes more moisture to stick on the metal, but we'll get to that. First, let's talk about the hot zones where atmospheric corrosion is most likely to happen. So the first place is marine and coastal areas, places like BC where it's really salty, um, the air is really salty, and that can cause more moisture to stick on our metal. Second place is high pollution areas like chemical plant refineries where the air is really heavy and thick and there's carbon dioxide in there to make it really acidic. Third place would be urban traffic tunnels. So enclosed spaces where high vehicles trap exhaust gases that come out of your car in those tunnels, causing tunnel infrastructure. So let's talk about the science now about atmospheric corrosion. So that's when oxygen and moisture um, create an invisible just moisture, and it creates an invisible film of water on top of our metal surface that acts like a tiny battery that pulls electrons away from the iron and creates rust. So while humidity is a primary fuel, we got to pay attention. While humidity is a primary fuel, urban pollutants like sulfur and coastal salt can become massive accelerators, causing metals to flake away faster. So that's all kind of a mouthful, but let's chop it up in little pieces. So how does water pull away its electrons? So so oxygens are electron hungry. O needs O2 minus. And when a drop of water sits on the iron, so think of a drop of water that sits on like an iron block. The oxygen from the air dissolves into the water. So it dissolves into the layer of water, not the layer, into the drop of water, and starts pulling electrons out of the iron atoms. And once those iron atoms lose its electrons, it becomes a positively charged ion. So this cation ion now isn't that strong. It can't really stick to this metal anymore. So it gets dissolved into the water. And once they dissolve the iron ions, they meet up with the oxygen and water to form iron oxide, which is rust. So that's how water pulls electrons away. So next thing is, how is salt water a super accelerator? So salt dissolves into many tiny charged particles called ions. Okay, so it dissolves into the water, causing ions, and those ions make the water much more conductive. Okay, because usually pure water isn't that good of a conductor, right? But salt water makes the water much more conductive, which makes it easier to it makes the bridge better to let electrons move from iron to oxygen way faster. Okay, so it makes the bridge faster. Also, salt is hygroscopic, so that means it literally pulls moisture out of the air. So it doesn't even need it to rain. You can keep the metal wet by pulling moisture out of the air onto the metal surface. Third thing is, how is urban pollution um, a booster, an accelerator for humidity, for atmospheric corrosion? So cities and industrial areas release gases like sulfur dioxide, SO2, or nitrogen oxide, so NO3, NO4, NO5, whatever. This is how it happens is gases mix with the humidity in the air that create acid rain. So acid rain is even more reactive than salt. It's even worse than salt because it provides hydrogen ions. And hydrogen is so bad for corrosion because hydrogen is H plus, right? It won't even wait for water. It can just take the oxygen itself, right? Because H plus is a positive charge and it attracts the negative electron charge. So hydrogen will attract the electron and take it away. And it'll leave the um it'll take away the electron, dissolving the iron much faster than plain water ever could. Another thing would be that hydrogen are also the smallest atoms in the universe, so they can tunnel in the solid metal, and once inside, they crowd together and create an internal pressure, and this makes the metal really brittle and prone to cracking. So this is hydrogen embrittlement, which I talked about 2 weeks ago, like in one of those videos, and that's how it kind of relates all back together. So hydrogen is bad for two reasons. Number one, it's got the H plus charge. It'll just take the electrons without even water being there. And the second thing is the weakening from the inside. So hydrogen embrittlement, it can turn a metal from ductile, bendy, to brittle, snappy. So now let's talk about what it attacks, the primary targets. So carbon steel is like the main thing it attacks, apparently it corrodes 5 to 20 times faster than galvanized steel and up to 200 times faster than aluminum. Um, Reinforced concrete, it also doesn't like that, and copper and silver. So that's my video for atmospheric corrosion. I'll see you guys in the next one.